On your mark, get set, go. Here we go. Okay, so today we are going to continue to evaluate functions. The difference is as we evaluate these functions, we're going to be plugging in some different things. In fact, we're going to be using kind of a unique rule. Nope. So, notice we plugged in numbers and we plugged in expressions yesterday. Today, we are going to try to evaluate this thing. F of a plus h minus f of a all over h. If you're anything like years past or third hour, you should enter some point today a state of confusion where you're like, I'm not sure I get this, but then you should come out of it and be like, oh yeah, I see exactly what I need to see. Okay? Trust the process, you'll be good to go, and I'll share with you why you're going to need this for the future. Very important skill. I'm going to start with the easy part. I'm going to start with f of a plus h. I'm going to start with f of a. If my function is x squared, who can tell me what f of a is? A squared. Is everybody okay with that? Sweet! If my function is x squared, then f of a plus h would be a plus h quantity squared. Right? No. So, what we want to do at this point is I've identified f of a plus h. I've identified f of a. Look at what they want me to do for the rule. They want me to do that minus that divided by h. So I'm going to do a plus h squared. That's my f of a plus h. And I will subtract what? A squared, and I divide it all by h. Good. That's the setup. Now we're going to have some simplifying involved. The first thing that we're going to do is we will expand the a plus h quantity squared. How do I do a plus h quantity squared? Is it a squared plus h squared? No. So you take a plus h times a plus h. What do you get when you take a plus h times a plus h? Nice job. A squared plus 2ah plus h squared and then minus a squared all over h. If you've done it correctly, you should notice that everything that doesn't have an h should cancel. Does it? Yeah, what cancels? A squareds are gone. Does everything else have an h? So what could I do to make it simplify with the denominator? Factor out an h. So h times 2a plus h divided by h. So it simplifies to 2a plus h. So you know you're done when, first of all, everything that doesn't have an h cancels, and also when the h in the denominator divides off. That's when you know you're done. Not too bad? Yeah, we're going to do two more, and then you're going to have some time to practice, and then we're going to get back to the more difficult ones. Let's try the next one. What's different about this is instead of a quadratic, it's linear, meaning it's x to the first power. I have it named g, which isn't any different. You can then do g of a plus h minus g of a all over h. So I'm going to set this up by writing g of a plus h and g of a.
So why don't you do just okay.
Because it doesn't say g of h.
Oh, okay.
So if g of x is 2x minus 3, then what is g of a? 2a minus 3. I plug in the a where the x is. You take the a, you put it where the x is. What would be g of a plus h?
2a plus 2a.
Good. I'm going to write it as 2 times the quantity, a plus h minus 3. We all okay? Now, here's where people make a mistake. Let's try to anticipate the problem so we don't make the mistake. We are going to have this thing right here minus that thing right there, correct? Now, I'm subtracting 1 term or 2 terms? 2. So you're going to have to make sure you subtract both of them. So make sure you distribute that subtraction sign. Let's write it out. We have 2 times a plus h minus 3. And then I'm going to subtract this. So I'm going to write parentheses 2a minus 3. Lots of times people make mistakes and they don't subtract the entire piece. They just subtract the front term. That's where you're going to make mistakes. All divided by h. Exactly. You could distribute the negative right away and write it as negative 2a plus 3, and that will be fine as well. Sir?
So basically, anywhere where there's an x on it, you put a plus h over it.
You got it, dude.
Okay.
All right. What do you get in the top? Good. If I've done it correctly, everything that doesn't have an h should cancel. Does that happen?
Yeah.
2 a's are gone. 3 a's are gone. 2h over h, which is?
2.
Good. Whoop, I'm sorry, 2h over h. Thank you. Thank you, Wendy. All right, we're going to try one more, and I'm going to have you practice a couple problems in your worksheet. We have 5x minus x squared. So I'll write h of. Good. And h of a. What would h of a be? Good. 5a minus a squared. And then if I plug in a plus h, I have 5 times a plus h minus a plus h quantity squared. So now I'm going to take the top one minus the bottom one all over h. So 5 times a plus h minus a plus h squared. Now we'll do what Marissa said. When we subtract this next piece, will it be a positive 5a or a negative 5a? Will it be a positive a squared or a negative a squared? Positive. All over h. Let's expand the top. 5a plus 5h. We already expanded a plus h squared, didn't we? We got a squared plus 2ah plus h squared, but now we're going to distribute a negative. So do you remember when we did this guy? When we expand this, you get a squared plus 2ah plus h squared, because you have to take it and multiply it by itself. Minus a squared minus 5a plus a squared. Now what? What should cancel? And I'm saying that because that's, you'll know when you make a mistake when you're like, I've got something that doesn't have an h and I can't get it to cancel. That's how you'll know. And it'll happen to a few of you. Okay? Does everything left have an h? So what do? Factor it out. And when you do factor it out, Notice the h's cancel.
Wait, shouldn't that... Wait. Never mind.
5 minus 2/8 minus h. Not too bad. Okay, we've introduced it. It's in our working memory. We have to put it into practice so we can get really good at it. Take out your worksheets. Your worksheets. My friend Marissa, say hi, Marissa. Just add broad shoulders. Say, Mr. Jens. Broad shoulders are in the way. Okay, here we go. So, from yesterday's worksheet, start working on 9, 10, and 11. You can skip 12. Start that right now. That is not all we're doing today. That is the basic practice. We've got a couple more that are more challenging, okay? So, okay, here we go. Turn back to those notes and look at the next example.
My sister got married, and so just all of these have H's in them, right?
Yep.
And so I would just have to take one H out of them.
You've got it. Okay, what is different about this example? It's a fraction. So we're back in the notes. It's the one you're looking at. There you go. So we're going to look at k of a plus h, and we'll look at k of a. What is k of a? Then if I do k of a plus h, that's going to be 2 over a plus h plus 3. Are we okay with that?
Yeah.
Oh, oh, fractions. Here we go. 2 over a plus h plus 3 minus 2 over a plus 3 all over h. Okay. Now, you can see in this situation we have a complex fraction. Do you remember early in the year where we learned complex fractions, how to simplify them? This is part of the purpose for which we did that. So you learned in order to simplify the fractions, you have to have one fraction at the top, one fraction at the bottom. How will I do that? Find common denominators, multiply top and bottom here by? Nope. No need to deal with h. Just leave h alone. You can see the denominator is already one fraction. It's h over 1. So we're just focusing on the top. This side I multiply by a plus 3 over a plus 3. Are there any questions about the setup so far? Okay. We're going to make this nice and easy. We're not going to make it complicated. And what I mean is, we're going to multiply the numerators, but we're not going to worry about the denominators. We'll just leave them in factored form. So what is 2 times a plus 3? Now, what should I distribute through here? Positive 2 or negative 2? Minus 2h? Minus 6. Over a plus 3 times over h over 1. All right, if we've done everything correctly, then everything that doesn't have an h should cancel. Does that happen? Yeah, the 6's are gone. The 2a's gone. I now have negative 2h in the numerator. So, in order to simplify this complex fraction, when you have a fraction over fraction, you should multiply by the? So I'll write it out so that we can all see it. Some of you see it already, but I'll write it out here. We have negative 2h in the numerator, and in the denominator we have h times a plus 3 times a plus h plus 3. Is that h finally going to cancel? It surely does. H is gone, leaving me with negative 2 over a plus 3 times a plus h plus 3. What's that? So the 2 is negative because when you distribute it here, better? Okay, last example for the day. Cross off M, let's do L. What's different about L? Okay, so there are 3 important problems we need to deal with in this situation. The first one that we need to deal with is a polynomial. You guys all did a great job with that. The second one is where you have a rational expression, which we just did. The third one would be the radical. So we have L of a plus h, and we have L of a. L of a is the square root of a plus 5. L of a plus h is the square root of a plus h plus 5. So I subtract the 2, square root of a plus h plus 5, and I subtract the square root of a plus 5, and it's all over h. And now we get to begin our little discussion about what to do. I mean, isn't the goal that we get the h's to cancel? So it's almost tempting to be like, well, I think that the a's will subtract, the 5's will subtract, and then the h's will divide off, and we get 1. So, I mean, come on, there's a little bit of voodoo math going on there, right? You wish you could do that, right? Just make up whatever we want, okay? Doesn't have to be logical. We can just do what we want. Any good ideas? I mean, the fact is, if I want that h to be out of the square root sign, I need that square root to go away, don't I? So everybody talks about squaring, but here's the challenge. Suppose you have the root of 3 over the root of 2, and you squared it. You get 3 over 2, right? Are those the same? They're not the same at all. In fact, if you look at this situation, you don't have an equal sign, do you? So when you have like the square root of x is equal to 9 and you square both sides, that's because you have an equal sign that you can do that. Do you have an equal sign here? There is no equal sign. So squaring both sides, there's no other side. There's just one side. So that unfortunately will not work. Oh, I like your thinking. You're like, I'm going to pull from somewhere. Maybe I'll get right. Anybody take Spanish? Yeah. Okay. All right, Braden, give us a verb in Spanish. Whoa. Comer. To eat. Or like hablo, right? Hablo means I speak, I talk. So what if I say it's a hablo? What if I say hables? What about hablan? What about hablamos? Yeah, so what am I doing at that point? I'm conjugating it, aren't I? I'm changing the ending. So when you don't know how to do math, you just do Spanish instead. What we are going to do, and it's beautiful. You're going to love it when you see it, okay? Don't fight it. It's really, really cool. It's going to work out. What we're going to do is we're going to multiply by the conjugate. Now, what is the conjugate? Let me explain that to you. Conjugate means that we change the ending. And so, for example, watch, because it works out really great. X minus 5 times x plus 5, right? if you multiply that out, everybody agree you get x squared and then a minus 25? Everybody see that the middles cancel, right? The reason why the middles cancel is because these two things are conjugates, meaning the ending changes. It changes from -5 to +5. So the great thing is when you multiply by conjugate, the middles disappear. So watch what happens when we multiply this. First of all, get this written down.
Yeah, it does feel like you are. You're so and you call us math. You really just lost me at Spanish. Yo, what does Spanish have to do with your own?
Well, it's the so for both this year and next year, we will use the word conjugate in multiple settings. And just like in Spanish, how you change the ending, in mathematics, we also change the ending.
You have to write that, the crossover episode.
All right, watch what happens, okay? Yes.
It's the
Shh.
we're just multiplying it by what's right.
Exactly. So let's look at what's in red, okay? Don't fight it. It works out perfect, okay? Look at what's in red. If you have this over this, what is this over this? 1. Is it okay to multiply something by 1? Yes. So it's fair game. Now watch this. I have the expression in blue times the expression in red. When you multiply these, what will you get? You're just going to get a plus h plus 5, right?
Wait, how do you keep square?
Yep. Okay. Now, watch the middles. Okay. If I multiply these two and these two, do you agree that if I multiply those two sets, they're going to be the same? It's just one's positive and one's negative. So that will end up disappearing, right? And then you have the last part, which will be square root of a plus 5 times square root of a plus 5, which is just a plus 5, right? Will it be positive or negative? Negative. So it'll be minus a minus 5. Isn't that nice? Multiplying by the conjugate is an extremely important step that you learn in college algebra. We use it a lot. It's not just going to be this time. It comes up multiple times throughout the year. Now, the bottom is just ugly. Don't judge it. It's disgusting, okay? So we just leave it as h times that quantity, square root of a plus h plus 5 plus square root of a plus 5. So just don't worry about the bottom. It's not very pretty. It's just the way it is. What do you notice about the numerator? Everything that doesn't have an h goes away, just like we planned. And now you have h over all that. Do the h's now cancel? And what is h over h? So we have 1 over square root of a plus h plus 5 plus the square root of a plus 5. Good work. We'll talk here in just a second. Go ahead and look at your